Okay, here's another problem from your homework. 1/2 cotangent of x over 2. Okay, so this one has a vertical dilation of 1/2 because that's the number in front of cotan. And the period, so period is pi over 1/2. Okay, because x over 2, if we take the x out here, it's 1/2 of x. So pi divided by 1/2 is 2 pi. Because instead of dividing by a fraction, we multiply by the reciprocal. So 2 pi is the period here. It has no phase shift and it has no vertical shifting. So cotangent, if you remember, hopefully you do, that cotangent has an asymptote through the origin, just like sine has a 0. So everywhere cotan or sine is 0, cotan will have an asymptote. So cotangent starts off with an asymptote through the origin, and now it's going to have another asymptote at 2 pi. Okay, so cotangent has asymptotes at the period. So a period asymptote at the origin, and then an asymptote at the next period, which in this case would be 4 pi. So we have an asymptote at 2 pi and an asymptote at 4 pi. And an asymptote at 0, which is the y-axis. So in between, exactly in the middle of your asymptotes is your 0. So we have a 0 at pi and we have a 0 at 3 pi. And we probably have a 0 over here at negative pi, just for fun. Okay? Now 1/2. 1/2 is our dilation factor. So we go to the middle of the asymptote and the 0. And if this is my positive 1, 1/2 is the value for y halfway between. Okay, and then on the other side, between the 0 and the asymptote, we have another point we can plot. So that's another point here at 1/2. So that's what your dilation does. It takes this plottable point that's in the middle of your 0 and your asymptote. That's normally at 1, right? The tangent of pi over 4 is 1. So this is the point that we are plotting. And it's the y value that we're adjusting. So what is normally at positive 1 is now going to be at 1/2. And we can continue doing this for all of the points that we can possibly see. So now that we have your plottable points in there, we can make your graph that starts on the upper left, okay, and swoops through these 3 points and then ends to the lower right. Okay, so this is the graph of 1/2 cotan of x over 2. And then, of course, we have it here also. It would swoop in and go down like that. Okay, so let's do another cotangent one here. And since we're on it, we might as well do it. 3 cotans of pi x. So we start with the vertical dilation. So vertical dilation of 3. The period is pi over pi. So this has a period of 1. Okay, no phase shift and no vertical shift. Which means we have an asymptote at the origin, okay, on the y-axis. And now we have an asymptote at 1. Literally the number 1, right? Not 1 pi, not 1 pi over 2, but of course, and I write pi in my silly brain. This number should be 1. We should have the value 1 right here. Okay, and then the next asymptote will be at 2. Because if you have pi as a b value, you're not going to have pi as your labels. Okay, we're going to have normal numbers, integers. So halfway between our asymptotes, we have a 0. So you have a 0 at 1/2, we have a 0 at 1/2, we have a 0 at negative 1/2. Okay, and now that plottable point is going to be halfway between and at positive 3. And then halfway between and at negative 3. Okay, so we always go halfway between your asymptote and your 0 in order to plot that point for tangent. This is the point that gets dilated, so we can actually tell what the dilation factor is. That's where we see the 3. So now that we have that graph, we can swoop in here. It's going to be a very, not very curvy, I guess, fairly flattish looking graph. that goes through all these points. And that is the graph of 3 cotangents of pi x. So if we have pi as your b value, you're not going to have a pi as your period, and you won't have any markings like that. It will be normal numbers. Okay, hope this helps.